So hello, my colleagues, and I hope everyone is doing well on a very rainy Saturday. And so someone had a question about Chapter 6, Problem 6-12 here. I guess that would be the 12th problem, right? But anyway, you got to keep these numbers straight. So it's involving bonds, right? Suppose you purchase a 10-year bond with a 6% annual coupon. So if it's a 6% annual coupon, that means that's the interest rate. You're going to get $6 a year. Okay, and it's all based on $100. You know, they reference it, even though it's $1,000. In this case it's $100 face value. Okay, everyone see that? So you'll get $6 a year. 6% of this. Now, if it was paid every 6 months, you'd get $3 every 6 months. So you hold the bond for 4 years and then you sell it, right, after receiving the fourth coupon. If the bond's yield to maturity was 5% when you purchased and sold the bond, and this is what they want to know here. All right, now let me just make one point. The interest rate for the bond has gone down from 6% to 5%. If interest rates go down, the price of the bond should go up. So the first thing before you even do the problem is the price of the bond, the current price of the bond should be above par. Okay, should be above 100. So you should say to yourself, okay, so if I get something less than $100, I made a mistake. All right? So you get this here, and you have this information. They want to know what cash flows will you receive and pay from your investment in the bond per $100 face value. Okay. So I highlighted a couple things here. I underlined. Here's the annual coupon rate. It's it's 4 years. He sold it after 4 years. The yield to maturity is 5%. And the bond per $100 face value is $100. Okay, so let's go through this solution. Okay, so what cash flows will you pay and receive from your investment in this bond per $100 face value? So to calculate the coupon payments, again, which we kind of did already, right? It's 6%, so 6% of 100 would be $6. Okay, so that's $6. So that would be $6, right? So we can compute the price of a bond using a financial calculator or a spreadsheet, which is kind of what I always do. So the price of the bond at time 0, where the yield to maturity is 5%. All right, so here's what we did. If you use Excel, you just plug in 10 years, right? I think they said it was a 10-year bond, right? And the coupon is, the yield to maturity you put in is 5%. This is inputs, and you're going to get a payment every year of $6. And when it matures, you'll get $100. Okay. Now, I don't know, there might be a problem here. They made both of these negative, so in Excel, maybe I'll try it and see what happens. Okay. So anyway, this is the present value they calculate. All right. Now, after the fourth coupon yield, 4 years have gone by, so you're only left with 6 years. Right? They want to know the price of the bond. Now it's starting to go down, right? As you're getting closer to maturity. This hasn't changed, right? This is still 5%, right? And this is the payment, and this is the face value. So this is the present value of the bond that they calculate. Now, what I normally do, I kind of think they did it a little backwards, in my opinion. I normally, since these would be cash flows coming to you, I would make these, I think, positive, and I believe this would turn out to be negative, which would be the money coming out of your pocket. So I think they did it a little different than I would do it. Okay. But you'll notice here they came out with a positive number, but then on the timeline, they showed it here as negative. So you could have just left it these as positive and made that, and that would have came out negative for you. All right, so I hope everyone's clear about that. So for part B, they want to know what the internal rate of return is, and I kind of did a video, I believe, and I told you you didn't have to worry about the equation. That all you had to do was use the IRR function in Microsoft Excel. In this case, they used the rate function. So you could use the rate function right here to determine that, or you could have used and it comes out to 5%. So they want to know what the internal rate of return was after those 4 periods that you had it. Okay, because here's the present value you put in, here's the 4 periods, here's the payment, and here's the face value that you calculated, right? So it comes out to basically the 5%, okay? Which basically is the yield to maturity, you may notice, right? So I brought up Microsoft Excel, and I just wanted to show you how you can use the internal. I use the internal rate of return function here. Okay, everyone see that internal rate of return? All right, so here's the cash flows. This is the present value which you would have paid it, right? Doing it for 4 years. And here's your cash flows: $6, $6, $6. And the last one, you have a cash flow of 100 and the final value of the bond plus the fourth. You have the fourth coupon, so you would add $6 to this for the fourth coupon. And you can clearly see when I take these and use the IRR function, I get 5%, which is just what they calculated here. So they use the rate function, and I use the IRR function. So either one will work in this case. Okay. So I hope everyone is clear about that. So I just want to highlight everything here. We'll draw lines. All right. So and here's the values I put in. And again, I use the IRR function, and you can clearly see it shows you the answer in 2 spots, right? Shows it there, and it shows it there. All right. So if I say okay, first of all, I got to fix this. Hold on. If I say okay, I would get 5%. So if I said okay, all right, sorry about that, and it says 5%, all right. So that's all you got to do for that, okay. I hope everyone's clear. So let me get rid of this. So the IRR function will perform the same feat as rate, except you got to know, and here's the equation, which is impossible to use, okay. So you have to kind of use the either you need Excel or a financial calculator for this, okay. All right, so I hope I did this problem justice for you, and I hope everyone is clear. All right, and everybody take care.